Good morning, students. In previous lecture, we have started with the different types of cells, connecting cells, the construction of dry cell, lead acid cell, nickel cadmium cell, and electric circuit. Also, we have studied about the different activity which are related with electromagnet. In today's lecture, we are going to learn about the different structures of the gadgets which are work on magnetic effect of electric current. The gadget is electric bell, that is very well known to us, electric bell, but we didn't know the working and the construction of electric doorbell that we are going to study in today's lecture. First, we will understand what is magnetic effect of electric current. For that, we will do one activity. Take the inside tray of an used up matchbox, which is place a small magnetic needle inside the tray. Now take a long connecting wire and wind it around the tray completely that electric circuit by connecting in it this wire, electric cell, plug key and the bulb. Mark the position of the magnetic needle and take a bar magnet near to the magnetic needle. What do you observe? Keep looking at the needle and close the plug key. The bulb will light up and you will realize that the current has started flowing. Does the magnetic needle change its position? Now open the plug key. Does the magnetic needle come back to the original position? What will you conclude from this experiment? You know that the magnetic needle is indeed a magnet. You have seen that the magnetic needle changes its direction when a bar magnet is taken near the magnetic needle. Also, you have observed that the magnetic needle changes its direction when a current starts flowing in the circuit. This means that magnetic field is created when an electric current flows in a wire. Hans Christian Overstreet made this observation first. When an electric current passes through a wire, a magnetic field is produced around the wire. So let's consider the second activity of electromagnet that we have studied, but let's do the revision. Here, take a wire, flexible copper wire having resistive coating, connect to the two ends of the wire in a circuit as shown in the figure. Also connect an electric cell and plug in the circuit. Keep 2 or 4 iron pins and small nails near the screw. Now start the current in the circuit by plugging the key as you can see in the figure. It will be noticed that the pins or nails have stuck to the tip of the screw. Will the pins continue to stick when the plug key is open? When the electric current flows in the wire, magnetism is produced in the coil around the screw, and because of that, the screw also attains the magnetism. As soon as the current is stopped, this magnetism vanishes. This system also screw is called as electromagnet, which you have seen various uses of electromagnet in 6th standard. So electromagnets are used to produce strong magnetic field which is useful in science research. Now coil behave as a magnet when current is flowing. As soon as current is flowing, the coil starts to behave as a magnet. So this is all about the electromagnet. In your notebook, you have to write the definition of electromagnet and its uses. Now let us study about electric bell. Many of you must have seen the simple electric doorbell. Open such a bell which is out of order, and figure depicts a bell with its outer cover removed. We see that there is an electromagnet inside. Let us understand the working of the cell. A copper wire is wound around an iron piece. This coil is act as electromagnet. An iron strip along with a striker is fitted near to the electromagnet. A contact screw is in touch with the strip. The electric circuit is connected as shown in the figure. The current flows in the circuit when screw is in contact with the strip, and hence the coil becomes a magnet and attracts the iron strip towards it. Therefore, the striker hits the gong and the sound is created. However, at the same time, the contact screw loses the contact with the strip and the current in the circuit stops. In this situation, the electromagnet loses its magnetism and the iron strip moves back and comes in contact with the contact screw. The electric current is then immediately restored, and again the striker hits the gong by the above process. This action repeats itself and the bell rings. So in this way, the structure and the working of the electric bell is happened. So students, you can also do the home activity. Also, we are going to learn about more about electric bell by some videos are showing the activity which are based on electric bell. Many of the gadgets which are working on this mechanism of magnetic effect of electric current that we will study in the further standard. But in 8th standard we are going to study only the electric bell. In your notebook, draw a structure of diagram of electric bell. Also write the construction and the working of electric bell from your textbook. Make a PDF of your notes and send it to me on my WhatsApp account. For any queries you can ask me.
Works. Most of us have seen it. You know, this bell also works on electromagnet. Confused? Let us first refresh our memories. We already know when the electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of electric current. Also, a current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. The power of this electromagnet can be increased by increasing the number of turns of the coil. It can also be increased by increasing the flow of current through the coil. Let us also not forget, electromagnet can also be turned off by stopping the electric flow of current which made it a magnet. Now that we are clear about the electromagnet, let us now understand how an electromagnet is used in the functioning of an electric bell. Let us see the simplified circuit of an electric bell with the switch in off position. It consists of a coil of wire wound on an iron piece bent to form U shape like a horseshoe magnet. A spring-loaded arm made of an iron strip is kept close to the electromagnet. This arm has a hammer attached to it at one end. Let us call it a clapper. A small gong or bell is also placed near the hammer. See, there is a contact screw near the clapper. Now, let us switch on the circuit and the fun begins. Right now, the clapper is in the contact with the screw, so the circuit is complete and the current flows through the coil. Due to the current flow, the coil becomes an electromagnet. The electromagnet then pulls the clapper towards itself. In this process, the hammer at the end of the clapper strikes the gong of the bell to produce a sound. Let us see What else happened when the electromagnet pulled the clapper and we heard the hammer striking the gong? Look closely. Right now, the clapper is not in contact with the screw. The circuit is broken now. So what will happen next? The current through the coil will stop flowing. Will the coil remain an electromagnet? No, it wouldn't. The coil is no longer an electromagnet. As we know, it's the flow of the current that gives the coil its magnetic power. So, it no longer attracts the clapper. The clapper springs away from the bell back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated again and again very quickly. Thus, the hammer strikes the gong every time the circuit is completed. This is how the bell rings. Interesting application of an electromagnet, isn't it? So, in a nutshell, by turning an electromagnet on and off, we made a useful thing, an electric bell. Using this electromagnet, we created the movement of the clapper to ring the bell. With the current flow, the electromagnet attracted the clapper, ringing the bell. But it also broke the circuit and stopped the current flow. Due to this, the electromagnet lost its magnetic power and the clapper went back to its original position, making the contact with the screw again. This made the circuit complete and again the clapper struck the gong. Great, isn't it? So the next time if you get any chance, do analyze the circuit.
Electric bell. Magnet is used in an electric bell. An electric bell has an iron hammer, structures of metal around which the wire is wound. When we press the button of an electric bell, the current begins to flow through the electric wire, turning metal structures into temporary magnets. The magnet attracts the iron hammer. The hammer strikes the metal bell to produce a sound. At this stage, the connection between the screw and the hammer is broken and the electric current stops. The magnetism of the coil is lost and the hammer goes back to its original position. The electrical circuit is completed by joining of the screw and the hammer, and the bell rings. The process is repeated and the bell rings intermittently.